Today in Capechi's Corner, we're going to look at the tangent ratio, which is a trigonometry ratio. In today's lesson, we're going to look at the tangent ratio, but there are actually three types of trigonometry ratios. They are sine, cosine, and tangent. Now, in the trigonometry ratios, we can only use these when we're looking at right triangles. And we have a phrase that a lot of geometry teachers use called SOHCAHTOA. And that kind of helps you set up the ratios. It's a little easier to memorize. The S stands for sine, and then O and H stands for opposite and over hypotenuse. And cosine is CAH, adjacent over hypotenuse. And tangent that we're going to look at today is opposite over adjacent. There will be a separate lesson on sine and cosine. When we're looking at the tangent of a given angle, so in this case tangent of angle A, remember we said tangent is TOA, we use that phrase. So the T stands for tangent, my numerator is opposite, so we're going to be opposite the given angle, and my denominator is going to be the A, it's going to be the leg adjacent to the given angle. So let's look at our first diagram. So what I have here, everything is labeled. So if I'm just talking about angle A, and I want to know what that ratio is going to be, my hypotenuse again is always opposite the right angle. And we're looking at the side that's opposite angle A, we would go there. And adjacent is the one right next to angle A, but it would never be the hypotenuse. So let's look at the given example we have on the bottom. We have some measurements here that'll make it a little easier. So if I'm looking at the tangent of A, again I want to go the side opposite A, which would be 12, over the side that's adjacent to angle A, which is not the hypotenuse, and that's 5, because the hypotenuse is 13, that has a separate name. If we're looking at the tangent of C, we would go the side opposite of C, which in this case would be 5, over the side adjacent to C, which is 12. In our first set of problems today, it says find the value of x, round to the nearest tenth. Now, you are going to use a calculator for this, so if you don't have one, just go grab one very quickly. In number 1, we realize that we are looking at 56 degrees. We do have a right angle, so we know we can use a trig function. And I have opposite, and I also have the side adjacent, so that's going to be tangent. So I'm going to say tangent of 56 is equal to opposite, which is x, over 32. So before I put in my calculator, let's see what we're going to do. I'm going to cross multiply here, right? This is really over 1. So I'm going to say 32 times tangent of 56 is equal to x. Now I put that whole thing in my calculator at once. I don't need to do it separately and then round tangent separately. And when I do that and I round to the nearest tenth, I have x is equal to 47.4. So that means that's the measurement for side x there. In number 2, we're going to do the same thing. I realize I have my measurement of my angle is 21, and again I have opposite over adjacent. So once again I'm going to use my tangent function. So I have tangent of 21 is equal to 30 over x. Now when I cross multiply this time, I have x times tangent of 21 is equal to 30. I have to divide both sides by tangent 21 to get x by itself. So x is equal to 30 divided by tangent of 21. Now again, I put that in my calculator, and when I round that to the nearest tenth, I have x is equal to 78.2. So the measurement of this side is going to be 78.2. So although we're using our calculators, you do need to have your algebra set up correctly. I wouldn't suggest skipping steps on this. Just write it out. It's not that much. And that way you can make sure that you are solving for x correctly. Now our next set of problems are slightly different. We're still going to be using tangent because we have opposite over adjacent. However, this time the unknown is the measurement of the angle, not the side. So let's see how we're going to do this. The directions say find y to the nearest degree. So I know that I have opposite over adjacent. So I'm going to set up my tangent. So I have tangent of y is equal to 8 over 5. Now on my calculator, the key I have to use is the inverse tangent. It looks like this, tangent -1. So that's the key I have to use to find the degree. So when I use that key and use my ratio 8/5, I have y has a measure of 58 degrees when I'm rounding to the nearest integer. I'll do the same thing for number 4. Again, I'm using my y is the degree I'm trying to find, so I have tangent of y, and I have to realize what I'm using here. I have opposite over adjacent, so I have tangent of y is equal to 6/8. Now I don't have to simplify that, 6/8, I'm just going to put it in my calculator anyway. So when I do that, I have y has a measurement of 37 degrees. Let's look at our last problem for today. It says find the value of w and z. So I have to take a look at the diagram that I have. I have an isosceles triangle, right, because my sides are marked that they're congruent. So that means my base angles are congruent. So that gives me 35 on the left-hand side base angle because my right angle on the base is also 35. Now let's see what I can use. I need to find w and z. And I realize if I look at this triangle on the left-hand side, if I use tangent of 35, my opposite is 200 and my adjacent is w. So when I use those measurements, again, I have w times tangent of 35 is equal to 200. And I can use my algebra, and w is equal to 200 divided by tangent of 35. So in the end, w is equal to 286. So I'm going to mark that here, 286. Now again, the mistake students make is looking at z and saying, well, then it has to be, that big triangle has to be a right triangle. But it's not necessarily the case. I only have a measurement of a right angle marked there, so I can't just use my 3 sides and decide that the z is my hypotenuse or something like that. So I have to be a little bit more creative. Again, I do realize that I have isosceles triangles, and these when I break this altitude up, I realize these triangles are congruent. So if my left hand side is 286, so is my right hand side. When I add those values together, I get z is equal to 572. So again, we're pulling a lot of different things in and using our trig functions, things what we've done before. You may have to use Pythagorean theorem, you may have to use 30, 60, 90, you may have to use information you know about isosceles triangles to get the values that you need.